Hello everyone, today we are going to learn Chapter 1 Locating Places on the Earth from your Social Science textbook. In this video, I'll be covering each and every line from the chapter so you don't miss anything important. Make sure to keep your notebook and pen ready and take notes while watching. This will help you remember the concepts better. You can pause or rewind any time to write things down. So, let's begin. First, we have a quote from Aryabhatta. The globe of the earth stands in space, made up of water, earth, fire and air, and is spherical. It is surrounded by all creatures, terrestrial as well as aquatic. Aryabhatta was a famous Indian mathematician and astronomer from around 500 CE, that is year 500 of the Common Era, which is equivalent to 500 AD, that is 1525 years ago. So, Earth is floating in space and Earth is made up of four main elements. Water, like oceans and rivers. Earth, like the land we live on. Fire, that means the heat inside the earth, like volcanoes or the hot core. And air, the air we breathe. It is shaped like a sphere. Sphere means a shape that is round, for example, a football or an orange. Terrestrial animals means animals that live on land like elephants, lions, etc. And aquatic animals. The animals live in water like fish, turtles and whales. So, the earth is a home for all kinds of living things, both on land and in water. And we have a picture of an old map. So, the big questions are, what is a map and how do we use it? What are its main components? What are coordinates? How can latitude and longitude be used to mark any location on the earth? How are local time and standard time related to longitude? We will learn answers for these questions in this chapter. Imagine that you are visiting a city for the first time. How would you find the places you want to visit? You might ask a local person for help or you might look at a map of the city. In previous grades, you learned a little about maps and in this chapter, we will study them in more detail. Let's imagine you are visiting a new city for the first time. You want to see fun places like a park, a museum or a famous building. But how will you know where to go? You might ask someone who lives there. That's called a local person. Or use a map. A map will show you where each place is and help you figure out how to get there. In your previous grades, you learned a little bit about maps, but in this chapter, we will study them in detail. We will see what maps can show us, how to read them and why they are so useful. Let us play a game. Examine the map of this small city, figure 1.1. Imagine that you just got off a train at the railway station and you want to visit the bank marked on the map. Which way would you go? Are there other possible ways? Can you locate the public garden, the school and the museum? If you want to proceed from the bank to the market, which way will you go? This is where a map comes in handy. Imagine you have a map of the city you have just arrived and you are standing at the railway station. You want to go to the bank. What do? You look at the map. See figure 1.1 in your book. First, we need to find the railway station on the map. Then, find the bank. Here, there are more than one way to reach the bank, isn't it? We can go like this and like this also. So, what do? You choose the shortest or easiest path from the railway station to the bank. Now, find these places on the map. The public garden, the school and the museum. You can find and mark these places in your textbook. Now, after visiting the bank, you want to go to the market. You look up the map again and you find the shortest route to the market. So, which is the shortest route? Yes, you can mark this route also. So maps are really helpful when you're not sure about the route or when you're in a new place. They show us directions, help us find landmarks, and guide us to choose the best path. A map is like a treasure guide. It shows you where things are and how to get to them. Notice the 4 arrows in the top right corner of the map. We will soon see how they point to some specific directions and make maps even more helpful. A map is like a treasure guide. Treasure guide is something that helps you find something valuable or important, like a hidden treasure. So, a map shows you where things are and how to get to them, just like in a treasure hunt. Now, look at the top right corner of the map. Do you see those 4 arrows? They are very important. These arrows point to the 4 main directions. North, usually at the top. South, at the bottom. East, to the right. And west, to the left. Let's explore. On the map in figure 1.1 given on page 8, mark the hospital. Look at the map and try to find the symbol or label for the hospital. It might be shown with a red cross or written as hospital. Here it is written as hospital. Mark or circle it on the map in your book. What is the meaning of the blue colored areas? Here we see some blue colored areas, right? What do you think it is? Yes, it is water bodies. On most maps, blue color usually stands for water, like rivers, lakes, ponds, or tanks. So, if you see blue colors in a map, they probably represent a water body. Which is farther away from the railway station? The school, the Nagar Panchayat, or the public garden? Let's first find the railway station on the map. Then locate the school, Nagar Panchayat, and the public garden. Look at the distance from the railway station to each of these places. Compare the distances on the map. So, which one is farther? The school is near to the railway station. The Nagar Panchayat is in the middle and the public garden is farther. So, public garden is farther from the railway station. As a class activity, form groups of 3 or 4 students each. Let each group try to draw a map of your school and some of the streets or roads that lead to it and a few neighboring buildings. At the end, compare all the maps and discuss. So you need to form a group of 3 or 4 students. Each group will work together to draw a map. You need to draw a map of your school. Include some streets or roads that lead to the school. Add a few neighboring buildings like houses, shops, parks, or anything nearby. Use simple symbols or pictures to show buildings, roads, trees, etc. After everyone finishes, compare all the maps. Talk about what is similar and what is different. A map and its components. From this simple example, we understand that a map is a representation or a drawing of some area. It may be a small area, a village, a town, etc. A bigger area, say your district or state, or a very large area like India or even the whole world. In a map, you look at the surface as if you are viewing it from the top. So from this example, we understand that a map is like a picture or drawing of a place. It shows us what the place looks like from above, as if we are flying in a helicopter and looking straight down. A map can show a small area like a village, town, or school. It can be a bigger area like your district or state, or a very large area like the whole country or even the entire world. And why do we look from the top? Because when we look from above, it's easier to see where everything is. Roads, buildings, rivers, and more. We can understand how places are connected to each other. We can easily plan how to go from one place to another. So in simple words, a map is a drawing that shows a place from the top, helping us to understand and explore it better. An atlas is a book or collection of maps. An atlas is a book or collection of maps that shows different places on Earth, like countries, oceans, mountains, and cities. As we will discover, there are several kinds of maps. So, there are several kinds of maps. Each one shows different types of information about the Earth. Some show land and water, some show countries and cities, and others show things like weather or population. Physical maps, which mainly show some natural features such as mountains, oceans, and rivers. See an example in figure 5.2 in this textbook. So what do we understand by this? A physical map shows the natural features of a place. That is, a map showing things that come from nature, not made by people. For example, if you look at figure 5.2, the second picture in chapter 5 of your textbook, you will see a physical map of the Indian subcontinent with some of its rivers. In this map, mountains are shown in brown and oceans and rivers are shown in blue. Only natural features are shown in this map. Political maps, which show details of countries or states, boundaries, cities, etc. For instance, a map of India with all its states, union territories and their capitals. So, political map is the opposite of the physical map. It shows how land is divided by people, not by nature. It tells us about boundaries or borders between countries or states. Through political map, we understand which country or state a place belongs to, where the borders are between different states or countries. And we can easily find the locations of important cities and capitals. So, if you look at a map and see mountains and rivers, it's a physical map. If you see country names and lines dividing them, it's a political map. Thematic maps with a specific kind of information examples include figure 6.3 and figure 8.1 in this textbook. A thematic map focuses on one particular topic or theme. Instead of showing everything like roads or cities, it shows specific information about a place. There are few examples in your textbook. See the third picture in chapter 6 in your textbook. Figure 6.3, map of some of the main settlements of the Indus-Saraswati civilization. This thematic map shows the main settlements of the Indus-Saraswati civilization. It gives information about where people lived during that time, mainly near rivers like the Indus and the river Saraswati. The map focuses on human settlement patterns rather than physical features. Also, see the first picture in chapter 8 in your textbook. Figure 8.1 is a thematic map of cereals and pulses from different regions of India. It shows what is grown where. Let's say you want to know which part of the country gets the most rain. Then you need to look at the thematic map about rainfall. So what we learned so far? Physical map shows the land and nature. Political map shows countries, states, cities and their boundaries. Thematic map shows information about one particular idea or theme. In addition, there are three important components of maps: distance, direction and symbols. You have already experienced the first two while navigating the map in figure 1.1. Let us now define them more precisely. Maps have three important parts: distance, direction and symbols. You have already seen how distance and direction work when you looked at the map in figure 1.1. Now we will see what these three parts mean more clearly. Have you ever wondered how a huge place can fit on a small piece of paper? It is all thanks to the map's scale. So, have you ever wondered how a huge place fits on a small piece of paper? Like how the whole country of India can be shown on a single page. For that, we must know what is a map scale. A scale on a map tells us how much the distance on the map represents the real distance on the ground. In our small city map, figure 1.1, let's say 1 centimeter on the map is equal to 500 meters in real distance. So, if you measure 2 centimeter between two places on the map, in real distance it means 2 into 500, that is 1000 meters or 1 kilometer. Let's see another example like map of India in figure 5.2 in chapter 5. At the bottom left corner of the map, there is a small ruler marked on the map itself. Let's take a ruler and measure this. It is 2.5 centimeter, but it represents 500 kilometers in real distance. So, if you measure a distance of the map using this scale, you can calculate how far apart places really are. Always check the scale on a map before measuring distances. So, the actual distance between 2 points represented on the map depends on the scale that the map is using. So, let's say you want to find the distance between Mumbai and Chennai. Here the scale is 2.5 centimeter equal to 500 kilometers. Now, measure the distance between Mumbai and Chennai in the map using a ruler. You will find the distance to be more than 5 centimeter. If 2.5 centimeter is 500 kilometer, then 5 centimeter is 1000 kilometer. Since the distance is more than 5 centimeter, the actual distance between Mumbai and Chennai is more than 1000 kilometer. So, if the scale number is bigger, then each centimeter on the map represents a larger actual distance. Let's explore. Draw a simple map of a school's playground. Let us assume it is a rectangle, 40 meter in length and 30 meter in width. Draw it precisely with your ruler on a scale of 1 centimeter equal to 10 meter. We need to draw a map of a school's playground. The playground is a rectangle. Length is 40 meters and width is 30 meters. Scale is 1 centimeter equal to 10 meter. Using the scale 1 centimeter equal to 10 meter, length on paper should be 40 meter divided by 10, that is 4 centimeter. Width on paper is 30 meter divided by 10, that is 3 centimeter. Draw a rectangle 4 centimeter long and 3 centimeter wide on your paper. Use the ruler to make straight lines. Write playground near the rectangle. Write the scale below your drawing. Scale is 1 centimeter equal to 10 meter. Now, measure the diagonal of the rectangle. How many centimeters do you get? Using the scale, calculate the real length of the playground's diagonal in meters. Now, draw a diagonal, that is a slanting line that goes from one corner to the opposite corner. Calculate the length using the ruler. It is 5 centimeter. The scale is 1 centimeter on map equal to 10 meter in real distance. So, 5 centimeter into 10 equal to 50 meters. So, the diagonal on the map is 5 centimeter and the real length of the playground's diagonal is 50 meters. Let us return to the 4 arrows at the top right of the small city's map. They point to 4 directions, which are north at the top and moving clockwise, east, south and west. These are called the cardinal directions, also cardinal points. Other than these, intermediate directions are also used. Northeast, NE, southeast, SE, southwest, SW and northwest, NW. Most maps simply have an arrow marked with the letter N, which points to the north direction. Let's look again at the 4 arrows at the top right corner of the small city's map. These arrows show us the main directions called cardinal directions or cardinal points. The arrow pointing up is north, N. Moving clockwise from north. Clockwise means moving in the same direction as the hands of a clock. When you look at a clock, it goes from 12, 3, 6, 9 and back to 12. That round movement is called clockwise, moving clockwise from north. East is to the right, south is at the bottom and west is to the left. Between these main directions, we have intermediate directions. Northeast, NE between north and east, southeast, SE between south and east, southwest between south and west, northwest between north and west. Most maps have only the N arrow showing which way is north. It helps you figure out all other directions. Let's explore. Consider the map of the small city again. Identify the correct and incorrect statements in the list below. First one is, the market is north of the hospital. Let's look at the map of the small city again and check each statement carefully using the cardinal directions we learned. First one is, the market is north of the hospital. Draw the cardinal directions with the hospital at the center and check which direction the market is. The market is below the hospital, which means south of the hospital. So, the statement is incorrect. Second one, the museum is southeast of the bank. Draw the cardinal directions over the bank and see which direction is the museum. The museum is below the bank, so it is in the south of the bank. Southeast means the museum should be down and to the right of the bank. But here it is not in that direction. So the sentence is incorrect. Third one, the railway station is northwest of the hospital. Draw the directions with the hospital in the center and check the position of the railway station. The railway station is at the northwest of the hospital. So, the statement is correct. Fourth one, the lake is northwest of the apartment blocks. Draw the directions with the apartment blocks in the middle. The lake is below and to the left, that is southwest. So, the statement is wrong. Taking your school as the starting point, do you know approximately in which cardinal direction your home is located? Discuss with your teacher and your parents. Draw a simple map from your school to your home. If you know the roads or streets between your school and your home, think about which way you travel. You can also talk to your teacher or parents and get help from them. Then draw the cardinal directions over your school. Now see which direction your home is in. In this example, the home is right and above. That means it is in the northeast direction. You can also check the direction of your home on your map and write it down in your notebook. Symbols are another important component of maps. Our map has small drawings of actual buildings and a few other elements. But there would not be enough space on the map of a large city or a country to draw them all. Instead, a symbol is used to represent these features. Symbols for different kinds of buildings, for instance, a railway station, a school, a post office. For roads and railway lines, and for natural elements such as a river, a pond or a forest. In that way, numerous details can be shown in the limited space available on a map. Now we are going to learn about symbols, which are very important. We look at maps of small areas. Sometimes we see tiny drawings of real things like buildings. But imagine a map of a big city or a whole country. There will not be enough space for every building, right? So we use symbols or small pictures or signs to show important places and things on the map. For example, a train symbol for the railway station, a book or school building symbol for a school, a letter symbol for the post office, a line to show roads or railway tracks, wavy lines or blue shapes to show rivers and ponds, green areas or tree symbols to show forests. To make maps more easily understood by a variety of users, Map makers use specific symbols. Different countries use different sets of symbols. The Survey of India, a government body, has fixed a set of symbols for maps of India or parts of India. A small selection of them is shown in figure 1.2 on page 12. Maps need to be easy to understand for everyone, right? So map makers use specific symbols that everyone can recognize. Different countries may have their own sets of symbols to show things like roads, buildings, forests, rivers, and more. This helps people from that country read maps easily. In India, the government has a special department called the Survey of India. They have a fixed set of symbols that are used on all official maps of India. This means any map made by the Survey of India will use the same symbols so people can understand them easily. A small selection of them is shown in figure 1.2 on page 12. First, we have symbols for railway line. For broad gauge, we use this symbol. Broad gauge means the distance between the two railway lines is wide or broader. It is stronger and can carry more weight. Trains can go faster. It is great for long distance travel and to carry heavy goods. Most of the railway tracks in India are broad gauge. For meter gauge, we use this symbol. This is used on smaller or older roads. In the past, many parts of India had meter gauge tracks, but now most of them are being changed to broad gauge, so trains can go faster and carry more people. And this is the symbol used for railway station. For metalled roads, we use this symbol. Metalled means a road that is strong and smooth. A pakka road made with cement or tar, that is strong and smooth. For unmetalled road, we use this symbol. Unmetalled means a kacha road that is temporary or weak, made with mud, wood or stones. Next is boundaries. For international boundary, we use this symbol. International boundary means line that separates two countries. And for state boundary, we use this symbol. Line that separates two states within a country. And this is for district boundary. Line that separates two districts within a state. For rivers, we use this symbol. For well, we use this symbol. For tank, this one. And for canals, we use this symbol. And for bridge, we use this symbol. And these symbols are for temple, church, mosque and chhatri. For post office, we use only PO. For post and telegraph office, we use PTO. For police station, we use PS. And this symbol is for settlement. Settlement means a place where people live. And this one is for graveyard. And for trees, we use this symbol. And for grass, we use this symbol. Learning these symbols help you read any map of India correctly. Let's explore. Draw a rough map of your locality or your village, including your home, school, and a few other important landmarks. Show the cardinal directions and use a few of the symbols shown in figure 1.2 on page 12 to mark some important features. So, we need to draw a rough map using symbols we learned so far. That shows your locality or village. In this example, you can see the symbol of broad gauge, bridge, settlement, etc. You can also draw your map using the symbols from figure 1.2. Mapping the Earth. Mapping the Earth is a little more difficult because our planet is not a flat surface. It nearly has the shape of a sphere. We say nearly because it is not a perfect sphere but is slightly flattened at the pole. However, in practice, we will consider it to be spherical. Representing a sphere accurately on a flat sheet of paper is not possible. To understand why, peel an orange in such a way that you have just 3 or 4 large pieces of the skin. Then, try and flatten them on a table. You will see that you cannot do it without tearing them at the edges. Mapping means making a map. Mapping the Earth means making a map of Earth. Mapping the Earth is not easy because our planet is not flat. It is shaped like a sphere, just like a football or a globe. And Earth is not a perfect sphere. It is little flat at the top and bottom called the poles. But to make things simple, we usually say it is a round sphere. It's not possible to show a round shape perfectly on a flat paper. To understand this, take an orange, peel it in 3 or 4 big pieces. Try to press those peels flat on a table. What happens? The peels will either tear, break apart, or they will fold, make wrinkles or bumps. That's exactly what happens when we try to draw the round Earth on a flat paper. It doesn't fit without changing its shape. Now, consider a globe, which is a sphere on which a map is drawn. This may be a map of the Earth, the Moon, the planet Mars, the stars and constellations in the sky, etc. Now, think about a globe. It is a round model of a planet, just like a ball. A globe has a map drawn on it. This map could show the Earth with countries, oceans, etc., or the Moon, or the planet Mars, or even the stars and constellations in the sky. So, a globe is a special way to show round things like planets and stars in their real shape. The physical object, like the one shown in the drawing on the next page, is a sphere that is generally made of metal, plastic, or cardboard. So what is a globe made of? It is usually made of materials like metal, plastic, or cardboard. This globe is a physical object, something you can touch, hold, and turn to see different parts of the map. Here we will study the globe representing the Earth's geography. Because the globe and the Earth have the same spherical shape, a globe will better represent the geography of the Earth than a flat map. So here we will learn about the globe that shows the Earth's geography. That is, its countries, oceans, mountains, and all places on Earth. Because the globe and the Earth both are round. The globe shows the Earth more accurately than a flat map. That is, a globe is better at showing the real shapes and positions of the countries and places on Earth. Let us now explore some of its features. Understanding coordinates. Imagine a big market in a city or town with neat rows of shops all the same size. You want to meet a friend at a stationery shop inside the market, but your friend does not know where the shop is. So, you would give directions like, meet me at 6 p.m. at the 7th shop in the 5th row from the entrance. This will allow your friend to precisely determine your location. Imagine you're in a big market. The market has rows of shops, like lines of shops going left to right. If you say, meet me at 6 p.m. at the 7th shop in the 5th row from the entrance, it means we need to find the 5th row from the entrance. Let's find the 5th row. The first row is closest to where you enter. So, let's count. 1, 2, 3, 4, 5. In that 5th row, count the shops one by one. 1, 2, 3, 4, 5, 6, 7. So, this is the 7th shop. That's exactly where you want to meet your friend at 6 p.m. So, this way, your friend can find the shop easily without getting lost. Now, consider a chessboard. To record moves by advanced players, letters are placed alongside the main pieces. From A to H, see the image, and numbers from 1 to 8 in between the two sides. This simple system allows players to mark each square and record every move. Here, the white side has just opened the game by moving the queen's pawn 2 squares forward, a very common opening. So, the pawn is said to have moved from D2 to D4. Now let's think about a chessboard. Chessboard has 64 squares arranged in 8 rows and 8 columns. Rows go left to right and columns go top to bottom. To help players remember and record their moves, the columns are labeled with letters from A to H and the rows are numbered from 1 to 8. You can see this in the picture. This way, every square on the board has its own name like D2 or D5. Let's say you want to find the location of this square. It's in column C and row 5. So, the location is C5. What about this one? It's in column F and row 3. So, the location of the square is F3. In this picture, we can see that the white player has started the game by moving the queen's pawn 2 squares forward. A pawn is like a foot soldier in an army. Each player gets 8 pawns which are placed in the second row. Row 2 for white, row 7 for black. Queen's pawn refers to the pawn that stands in front of the queen. Pawn is the smallest piece but it goes first in the battle. So, here pawn is moved from square D2 to square D4. Let's explore. Using the same terms, write down your move if you play back and respond with the same move. So now it's your turn to play as black. If you move the queen's pawn, that is the pawn in front of the queen 2 squares forward. 1, 2, what is the location? D5. So what was the original location of the pawn? D7. So the pawn moves from D7 to D5. You can also try to think of your move and write it down using the letters and numbers. The system used in these two examples may be called a system of coordinates. Thanks to their 2 coordinates, the stationary shop as well as the chess square on the chessboard can be precisely determined. What is the system of coordinates? The method we use to locate the stationary shop in the market is similar to how we identified the squares on the chessboard. Both use a system of coordinates because both places have 2 coordinates like the row and the shop number or the letter and number on the chessboard. You can find the exact spot easily. So thanks to these 2 coordinates, you can always say exactly where something is. A similar system of coordinates is used in the world of maps to determine the location of any place on a map. Let us see how this system works. Just like we use 2 coordinates to find the shop in the market or a square on a chessboard, maps also use a similar system of coordinates. The system helps us find the exact location of any place on the earth using the 2 numbers. Let's learn how the system works and how it helps us find places on a map easily. Latitudes. Let us return to the globe. It is easy to identify the North Pole and the South Pole on it. Rotate the globe. While it rotates, the fixed points at the top and the bottom are the 2 poles. Halfway between them is the equator. Note the circle marking it, figure 1.3. Let's go back to the globe. It's easy to find the North Pole at the very top and the South Pole at the very bottom of the globe. The North Pole is the northernmost point on Earth, located in the Arctic Ocean. The South Pole is the southernmost point on Earth, situated on the continent of Antarctica. So if you spin the globe, these 2 points stay in the same place. The top and bottom don't move. Halfway between the North Pole and the South Pole, there is an imaginary line called the equator. Look for the circle that goes around the middle of globe. That's the equator. You can see it in figure 1.3. Imagine that you stand on the equator and travel towards one of the poles. Your distance from the equator increases. Latitude measures this distance from the equator. At any point of this travel, you can draw an imaginary line that runs east and west parallel to the equator. Such a line is called a parallel of latitude and it draws a circle around the earth. Again, it is easy to note on the globe that the largest circle is the equator, while the circles marked by the parallels of latitude grow smaller as we move northward or southward, figure 1.3. So now we are going to learn what is latitude. Imagine you're standing on the line of equator, the line around the middle of the earth. Now, if you start traveling toward either the North Pole or the South Pole, your distance from the equator gets bigger. Let's say you are traveling towards the North Pole. So, your distance from the equator gets bigger. Latitude is the way we measure this distance from the equator. At any point during your travel, you can imagine a line that goes east to west, parallel to the equator. Parallel means they never meet or cross each other. They stay the same distance apart no matter how far they are. This line is called a parallel of latitude and it goes all the way around the earth making a circle. On a globe, you will see that the biggest circle is the equator right in the middle. As you move closer to the poles, the circles made by the parallels of latitude get smaller and smaller. Latitudes are expressed in degrees by convention. The equator is latitude 0 degree, while the latitude of the two poles are 90 degree north and 90 degree south respectively. This is noted 90 degree N and 90 degree S. So latitudes are measured in degrees. People around the world agreed on a standard way to measure and describe latitude. That is by using degrees. The equator is 0 degree latitude. That is 0 degrees. The North Pole is 90 degree north, written as 90 degree N. The South Pole is at 90 degree south, written as 90 degree S. So, when we say a place is at a certain latitude, we are saying how far it is north or south from the equator. For example, moving north from the equator, we have 15 degree north, 30 degree north, 45 degree north, 60 degree north, 75 degree north, and finally the North Pole at 90 degree north. Similarly, moving south from the equator, we have 15 degrees south, 30 degrees south, 45 degrees south, 60 degrees south, 75 degrees south, and then the South Pole at 90 degrees south. I hope this helps you understand how latitude is used to measure the distance between a place and the equator. There is a connection between latitude and climate. Around the equator, the climate is generally hot. It is also called torrid. As you travel away from the equator towards one of the two poles, in other words, as your latitude increases, the climate becomes more moderate or temperate, and closer to the north or south pole, the climate grows colder or frigid. You will learn in science why this is so and also why we experience different seasons in the course of a year. So what we learn here? Latitude is not just a number. It helps explain the kind of weather or climate a place has. Near the equator, that is 0 degree latitude, the climate is usually hot. This hot area is called the torrid zone. When you travel away from the equator towards the poles, north or south, the climate becomes moderate or comfortable. This is called the temperate zone. Near the North Pole or South Pole, that is 90 degree N or 90 degree S, the climate is very cold, which is called the frigid zone. Later, you will learn why this happens and why we have different seasons during the year. Longitudes. Imagine now that you travel from the North Pole to the South Pole by the shortest possible line. Observe the globe. You will see that instead of passing through Europe and Africa, you could just as well pass through Asia. The distance will be the same. These lines are called meridians of longitude. Figure 1.3. They are all half circles running from one pole to the other. Now, let's say you're traveling from the North Pole straight to the South Pole in the shortest way possible. When you look at the globe, you will see that you can pass through many different places. Like, you can pass through Europe like this, or like this through Africa, or like this through Asia. But the distance from the North Pole to the South Pole stays the same, no matter which path you take. This means that all directions from the North Pole to the South Pole are equal. These lines that run from the North Pole to the South Pole are called meridians of longitude. You can see them in figure 1.3. These are half circles that connect the two poles. You will also learn in science that the Earth spins on its axis. To put it simply, let's place a desk lamp a little away from our globe focused on it. And imagine that this is the sun illuminating the Earth. Slowly rotating the globe eastward, we can note that for some places on the Earth it is morning, while for others it is midday, evening or night. When it's breakfast time in one country, it's lunch time in another. And in a third country, people are fast asleep. That is why by measuring the longitude of a place, we will also be measuring the time at that place. Let us see how. So we will be learning in science that the Earth spins around an imaginary line called its axis. To understand this better, let's try a simple activity. Place a desk lamp a little away from a globe and shine its light on the globe. The lamp acts like the sun and the globe represents the Earth. Now, if you slowly turn the globe eastward, the same direction the Earth spins, you will notice for some places it's morning because the light is just beginning to fall there. The sun is rising in those places. For others, it's midday because they are facing the lamp directly. This is where the sun is highest in the sky. For some, it's evening or night because the light is moving away or not reaching them at all. These places are in shadow, just like night on Earth. So, when people in one country are eating breakfast, in another country, it might be lunchtime. And in another country, people are fast asleep. The Earth spins and as it turns, different paths face the sun. This is what causes morning, afternoon and night. That's why when we measure the longitude of a place, that is its position from east to west, we can also figure out what time it is there. We will find out how that works. To measure longitudes, we need to define a reference point called the prime meridian. Figure 1.3 on page 15. It is also called Greenwich Meridian because in the year 1884, some nations decided that the meridian passing through Greenwich, an area of London in England, could become the international standard for the prime meridian. It is marked as 0° longitude. So, to measure longitudes, we need a starting point called the prime meridian. The prime meridian is an imaginary line that is marked as 0° longitude. It's also called the Greenwich Meridian because in 1884, many countries agreed to use the line passing through Greenwich, a place in London, England, as the starting point for measuring longitude. This line helps us know how far east or west a place is from the prime meridian. And you can see this prime meridian on the globe in figure 1.3 on page 15. Just as latitude is a measure of the distance from the equator, if you travel towards one of the poles, longitude is a measure of the distance from the prime meridian if you travel along the equator. Longitude too is measured in degrees, westward or eastward. It increases in value from 0° to 180° with the letter W or E added. For instance, using round figures, New York's longitude is 74° west, while Delhi's is 77° east and Tokyo's is 140° east. So just like latitude measures how far you are from the equator when you travel north or south, longitude measures how far you are from the prime meridian when you travel east or west. Longitude is also measured in degrees. It starts at 0° at the prime meridian. Going eastward, longitude increases up to 180° east. E means east. Going westward, longitude increases up to 180° west. W means west. For example, New York is at about 74° west, 74 degrees west of the prime meridian. Delhi is at about 77° east, 77 degrees east of the prime meridian. and Tokyo is at about 140 degree east. Don't miss out. As you can see on the globe of meridians of longitudes, 180 degree west and 180 degree east are the same longitude. So this longitude is noted 180 degree, omitting the letter W or E. On the globe, you will notice that 180 degree west and 180 degree east are actually the same line. That's because 180 degree west and 180 degree east meet on the exact opposite side of the prime meridian. So instead of calling it 180 degree east or 180 degree west, we just say 180 degree. Latitude and longitude together are the two coordinates of a place. With them, you are now able to locate any place on Earth. You can now understand a statement such as Delhi lies at 29 degree north latitude and 77 degree east longitude. These values are rounded off, not exact. So latitude and longitude are like two coordinates that help us find the exact location of any place on Earth. Using these two numbers, you can say exactly where a city or country is. For example, Delhi lies at 29 degree north latitude and 77 degree east longitude. So what are the coordinates here? 29 degrees north and 77 degrees east. What does this mean? Delhi is about 29 degrees north of the equator and about 77 degrees east of the prime meridian. Remember, these numbers are rounded off to make it easier to understand. Now, you can also use latitude and longitude to find places anywhere in the world, isn't it? Figure 1.3 on page 15 shows the parallels of latitude and the meridians of the longitude together on the globe as blue lines. All these lines together constitute a grid for the globe. They are also called grid lines. In figure 1.3 on page 15, you can see the parallels of latitude and the meridians of longitude drawn on the globe as blue lines. All these lines together make a grid around the globe, and these lines are called grid lines. So what are grid lines? Grid lines are imaginary lines drawn on a globe or map. They include parallels of latitude, lines that go east to west, and meridians of longitude, lines that go north to south. Together, these lines form a grid, just like the squares on a chessboard or graph paper. This grid helps us find the exact location of any place on Earth by giving its two numbers, its latitude and longitude. So grid lines make it easy to locate places on maps and globes. Let's explore. If the globe or atlas in your class has well-marked latitudes and longitudes, try to note down approximate values for the latitude and longitude of Mumbai, Kolkata, Singapore, and Paris. If your globe or atlas has clear lines for latitude and longitude, look for these cities on the globe. Then note down its latitude, how far it is north or south from the equator, and its longitude, how far east or west from the prime meridian. This will help you practice using grid lines to find places on Earth. First, we have Mumbai. Mumbai is located on the west coast of India, somewhere here. So, its coordinates will be approximately 19 degree north and longitude 72 degree east. Next is Kolkata. Kolkata is located in eastern India, specifically in the state of West Bengal, approximately here. So what will be its latitude? 22 degree north and longitude 88 degree east. Next one is Singapore. We need to find Malaysia first because Singapore is located at its southern tip just below Malaysia. So let's find Malaysia. Malaysia will be somewhere here. And below Malaysia, a tiny dot, that's Singapore. Singapore is a small island, city and country at the same time. So its location is latitude almost 1 degree north and longitude 104 degree east approximately. The last one is Paris. Europe will be here. Look for a country that's kind of shaped like a hexagon. That's France. Now, in the northern part of France, you will find a city, Paris, the capital of France, and famous for the Eiffel Tower and one of the fashion capitals of the world. Its location will be approximately 49 degree north latitude and 2 degree east longitude. Figure 1.4. This sketch shows how the prime meridian divides the earth into the western and eastern hemispheres, while the equator divides it into the northern and southern hemispheres. Here we have the prime meridian and here equator. The prime meridian divides the earth into the eastern hemisphere and the western hemisphere. The equator divides the earth into the northern hemisphere and the southern hemisphere. The prime meridian divides the earth vertically into two equal halves, while the equator divides the earth horizontally into two equal halves. Don't miss out. The Greenwich meridian is not the first prime meridian. There were others in the past. In fact, many centuries before Europe, India had a prime meridian of its own. Figure 1.5. It was called Madhyareka or middle line and passed through the city of Ujjaini, today Ujjain, which was a reputed center for astronomy over many centuries. Varahamihir, a famous astronomer, lived and worked there some 1500 years ago. Today we use the Greenwich meridian as the prime meridian. But did you know Greenwich was not the first prime meridian in history? Long before Europe, ancient India had its own prime meridian. It was called Madhyareka, which means middle line in Sanskrit. This line passed through the city of Ujjaini, today known as Ujjain, in the state of Madhya Pradesh. Ujjain was a very important place for astronomy many centuries ago. A great Indian astronomer named Varahamihir lived and worked there around 1500 years ago. He and other scholars studied the sky, stars, using Ujjain as the center point. Indian astronomers were aware of concepts of latitude and longitude, including the need for a zero or prime meridian. The Ujjaini meridian became a reference for calculations in all Indian astronomical texts. So, a long time ago, Indian astronomers already knew about latitude and longitude. They also understood that we need a special starting line called a prime meridian to help with these measurements. In ancient India, the city of Ujjaini, which is now called Ujjain, was used as the starting point. This Ujjaini meridian became the main line for making calculations in all Indian astronomy books. The map shows a few ancient Indian cities close to the Ujjaini meridian. Some are very close to it, while others are a little away. That is because measuring longitude required accurate timekeeping, which was not as precise then as it is today. This map shows some old Indian cities near the Ujjaini meridian. Some cities are very close to this line, while others are a little farther away. This happened because long ago it was hard to measure longitude exactly. Accurate longitude needs very precise timekeeping, which was not easy in ancient times. The cities that are marked with circles on the map were mentioned in old astronomy books. You can also see their modern names written next to them. Here we see Kurukshetra, Rohitaka. Rohitaka is also known as Rohtak. Delhi, Malavangara or Nagar, Ujjaini, which is Ujjain today. Mahishmati, which is Maheshwar. Kolkata, Mumbai, Chennai, Bengaluru, Kumari or Kanyakumari, which are modern cities now. Figure 1.6. This map, published by the Survey of India, shows the country's outline along with a few parallels of latitude and meridians of longitude. India's latitudes extend approximately from 8 degree north to 37 degree north, and longitudes approximately from 68 degree east to 97 degree east. The two colors have been added. So, in figure 1.6, which shows the outline of India, we can see some parallels of latitude, which are over here. These are parallels of latitude. And these are meridians of longitude. India's location on the globe is between about 8 degree north to 37 degree north latitude. This means India stretches from 8 degrees north of the equator to 37 degrees north, and about 68 degrees east to 97 degree east longitude, which means India stretches from 68 degrees east to 97 degrees east of the prime meridian. Understanding time zones. Let's make the globe rotate again from west to east. That is how our planet spins around its axis, making a full turn every 24 hours. A full turn is 360 degree. So this means 15 degree per hour. 15 into 24 equals 360. Let us now mark the meridians of longitude every 15 degree. Moving eastward from the prime meridian, we get 0 degree, 15 degree east, 30 degree east, 45 degree east, and so on every 15 degree up to 180 degree east. It is the same as adding 1 hour of local time with each meridian. If it is 12 p.m. or noon at Greenwich, it is 1 p.m. local time at 15 degree east, 2 p.m. at 30 degree east, and so on. But going westward, it is the other way round. 11 a.m. local time at 15 degree west, 10 a.m. at 30 degree west, etc. The earth spins around like a top. This spin is called rotation. It turns from west to east and it takes 24 hours, that is one whole day, to make one full turn. A full turn is like turning in a big circle, and a circle has 360 degrees. Since Earth turns 360 degree in 24 hours, to calculate how much it turns in 1 hour, we divide 360 by 24, which is equal to 50. So, Earth turns 15 degrees every hour. That means for every 15 degree, 1 hour passes. Now, on the globe, we draw lines from the North Pole to the South Pole called meridians of longitude. Let's start with the main one, that is prime meridian at 0 degree, which passes through Greenwich, England. If we move east from Greenwich, let's say it's 12 noon at Greenwich. At 15 degree east, it's 1 p.m. And at 30 degree east, it's 2 p.m. At 45 degree east, it's 3 p.m. and so on. And if we go west from Greenwich, at 15 degree west, it's 11 a.m. At 30 degree west, it's 10 a.m. At 45 degree west, it's 9 a.m. and so on. That is, we add 1 hour to the previous time zone when we move east from Greenwich Meridian. At 15 degree east, it is 1 hour later. At 30 degree east, it's 2 hours later. At 45 degree east, it's 3 hours later and so on. Similarly, when we move west from the prime meridian, we subtract 1 hour from the previous time zone. At 15 degree west, it's 1 hour earlier. At 30 degree west, it's 2 hours earlier. At 45 degrees west, it's 3 hours earlier, and so on. This system helps us know the local time at different places on Earth based on how far east or west they are from Greenwich. Let's explore. Two friends, one sitting in Porbandar, Gujarat, and the other in Tinsukia, Assam, are speaking on the phone late afternoon. The latter remarks that the sun has set in Assam and it's now dark. The former is surprised and says, "But it's still full daylight here." Explain why. And as a class activity, calculate the difference in local time between those two cities. Hint: for now, consider the difference in longitude between Porbandar and Tinsukia to be 30 degree. Later, you can find out the precise value. So, two friends are talking on the phone late afternoon. One is in Tinsukia, Assam, in the east of India. The other is in Porbandar, Gujarat, in the west of India. The friend in Assam says, "The sun has set here. It's already dark." The friend in Gujarat is surprised and says, "It's still daylight here." Do you know why this happens? This happens because the earth rotates from west to east, which means the eastern parts of the earth see the sun first, and the sun sets there earlier. So, since Assam is in the east, the sun rises and sets earlier there. Gujarat, being west of Assam, will see the sunrise and sunset later. That's why it's already dark in Assam but still light in Gujarat. As a class activity, we have to find the local time between these two cities. We have already learned that every 15 degree of longitude equals 1 hour time difference. Here, it is given that the difference between Porbandar and Tinsukia is 30 degree. So, we have to divide 30 degree by 15 degree, which is equal to 2. So, Tinsukia is 2 hours ahead of Porbandar. So, if it's 5 p.m. in Porbandar, it's already 7 p.m. in Tinsukia. That's why the friend in Assam is already in the dark, while the friend in Gujarat still sees daylight. The same method can be used to calculate the local time of any place on the earth. But it would not be convenient for a country to use many local times. That is why most countries adopt a standard time based on a meridian passing through them. Indian Standard Time IST is 5 hours 30 minutes, also noted 5.5 hours ahead of the local time at Greenwich, called Greenwich Mean Time or GMT. So we learned that the local time at a place depends on its longitude. So in theory, every city could have its own local time, but that would be really confusing. Imagine trains running on different times in every city, schools starting at different times in nearby towns, TV shows playing at different times everywhere. It would be very hard to manage. So, to keep things simple, most countries use one common time for the whole country, which is called standard time. Each country chooses one main line of longitude, that is a meridian that passes through it, and uses the local time at that line as the standard time for the whole country. In our country, we use Indian Standard Time, that is IST. IST is based on a line that passes through 82.5 degree east longitude. This meridian goes near Mirzapur, Uttar Pradesh. IST is 5 hours and 30 minutes ahead of Greenwich Mean Time, that is GMT. This can be written as GMT plus 5:30. So, if it's 12 noon in Greenwich, England, it is 5:30 p.m. in India. So, what is GMT? GMT is Greenwich Mean Time, which is the starting point for measuring time around the world. It is the local time at the prime meridian, that is 0 degree longitude in Greenwich, London. So, if it's 6 a.m. in Greenwich, what will be the time in India? We need to add 5:30 to the Greenwich Mean Time. So, GMT plus 5:30. It will be 11:30 a.m. in India. Let's explore. Written to the two friends sitting in Gujarat and Assam. Use this example to explain the difference between local time and standard time. Let's go back to our example of two friends. Let's say Ravi lives in Porbandar, Gujarat in the west of India, and Amit lives in Tinsukia, Assam in the east of India. The sun rises earlier in Assam than in Gujarat. So, Amit sees the sunrise at 5 a.m. but Ravi sees the sunrise at 7 a.m. that is 2 hours later. This difference in sunrise times is because of the Earth's space and the way it rotates. This is what we call local time, the time based on the position of the sun in that particular place. But if we let each city to use its own local time, things will get confusing. Like TV shows, train timings, school timings, all would be different across cities. So what's the solution? India uses one standard time for the whole country, which is called Indian Standard Time or IST. This means that both Ravi and Amit follow the same clock, even though the sun rises at different times in their cities. So, if the sun rises earlier in Assam, both Ravi and Amit will say it's 6 a.m. IST when they wake up. Same time on the clock, even if the sky looks different. In short, we can say Local time is the time based on the position of the sun in each place, which can be different. And standard time is one common time used in the whole country, that is same everywhere. If you use local time, the sun rises in Assam around 5 a.m. and the sun rises in Gujarat around 6:30 a.m. But by IST, both places use the same clock time, even though the sun behaves differently in both places. So what's the difference? Local time is the time based on the sun at your place, and standard time is the time used officially in the whole country. Local time is different for Assam and Gujarat. Standard time is same for all of India. Assam's local time is earlier than Gujarat's. Standard time both follow the same IST, GMT plus 5:30. All these standard times are organized in time zones, which broadly follow the zones of 15 degree in the graph, figure 1.7. But let us consider the world map below, figure 1.8. We can see that the lines dividing the time zones are not fully straight. This is because they have to respect each country's standard time and therefore tend to follow international borders. The numbers written inside some countries are the numbers of hours to be added to GMT to get their standard times if they have a positive sign, or subtracted from GMT if they have a negative sign. We already know that the Earth turns 360 degree in 24 hours. So each 15 degree of longitude is equal to 1 hour. This makes it easier to know the time in different parts of the world. Each time zone has a time that is ahead or behind GMT, that is Greenwich Mean Time. If you look at the world map in figure 1.8, you will notice that the time zone lines are not perfectly straight lines. Instead, they zigzag and curve around countries. This is because each country wants to have a single standard time or a few in the case of large countries. So the lines try to follow country borders. They try to avoid dividing a country into too many time zones. Here we see numbers like +4, +8, -7, -10, +12. These numbers tell you how many hours to add or subtract from GMT to get that country's standard time. For example, India is +5.5, that is 5.5. So IST, that is Indian Standard Time, is GMT plus 5 hours 30 minutes. Japan is +9. So Japan time is GMT plus 9 hours. Here it is -10. So we have to subtract -10 hours from GMT. Don't miss out. From the above explanation, it may seem as if every country has one standard time. That is not always the case. Some countries like Russia, Canada, or the USA are too large to have a single time zone. The USA has 6 time zones and Russia has 11, which means that traveling across Russia from east to west, you will need to readjust your watch 10 times to align with the local time. So, do all countries have one standard time? No. It might seem like every country uses just one time for the whole country. But some countries are so big that the sun rises and sets at very different times in different parts of the country. So, using just one standard time wouldn't work well. It would be too early in some places, too late in other places. Some very large countries use more than one time zone. Let's look at a few examples here. Russia. It is the largest country in the world. Russia uses 11 time zones. That means if you travel across the country, you will need to change your watch 10 times. United States. The USA has 6 time zones. And Canada also uses 6 time zones just like USA. These countries are very wide, so they follow the rule of 15 degree equals to 1 hour. So, as you move across the country, the local time changes every 15 degree of longitude. Similarly, the globe in figure 1.9 centered on India shows standard times with respect to GMT for a few countries. Figure 1.9, a few time zones with respect to GMT in Africa and Eurasia. Eurasia means Europe plus Asia. It's one big piece of land that includes both continents, Europe and Asia. Here, you can see a globe that shows the standard times of different countries compared to GMT. The globe is centered on India. And you can see some countries are ahead of GMT. Standard times are written as plus or minus numbers compared to GMT, that is Greenwich Mean Time. The plus sign means the country is ahead of GMT. The minus sign means it is behind GMT. India's time is GMT plus 5.5. That means when it is 12 noon in Greenwich, it is 5:30 evening in India. India is 5 hours and 30 minutes ahead of GMT. China is plus 8. So, when it is 12 noon in Greenwich, it is 8 p.m. in China. Finally, while the prime meridian was fixed at Greenwich, the opposite line at approximately 180 degree longitude is called the international date line. We already learned that the prime meridian is the 0 degree longitude line. It goes through Greenwich, England, and is the starting point for measuring time around the world. But what about the opposite side of the earth? That's the line at 180 degree longitude, and it's called the international dateline or ideal. The international dateline is special because it marks the place where the date changes on the calendar. That is, when you cross it, the day changes. If you go from west to east, you go back one day. And if you go from east to west, you move ahead one day. It zigzags a bit to avoid splitting countries or islands into different dates. As you can see on the map, the plus 12 and the minus 12 time zones touch each other at this line. If you cross it by ship or plane, you need to change the date in your watch. If you cross it traveling eastward, you subtract a day, say from Monday to Sunday. If you cross it traveling westward, you add a day from Sunday to Monday. We said that the international dateline is approximately at 180 degree longitude, as it deviates in places to avoid dividing some countries into two different days. So here we can see that the plus 12 and minus 12 time zones meet at the international dateline around 180 degree longitude. If you cross the line while traveling east, for example, by plane or by ship, you go back one day. So, if it's Monday, you need to change your watch to Sunday. If you cross it while traveling west, you add one day. So, if it's Sunday, you need to change your watch to Monday. The dateline bends around some countries and islands so that they don't have two different days. Remember, eastward means subtract one day, westward means add one day. Before we move on, maps are a very useful tool to represent an area of the earth, whether small or large. The main components of maps are distance, direction, and symbols. So what are maps? Maps are pictures or drawings that show us a part of the earth. They can show a small area like your neighborhood, a big area like a whole country, or even the world. To help us understand maps easily, every map has these important parts. Distance, which tells us how far apart places are on the map. Maps have a scale like 1 centimeter equals 1 kilometer to show real distances. Direction, this helps us know which way is north, south, east or west on the map. Most maps have a compass rose or arrow showing north. Symbols. Map use small pictures or signs to show things like rivers, mountains, cities, roads, and more. There is usually a map key that explains what each symbol means. Every place on the earth has a location which can be precisely defined with the help of a grid of latitudes and longitudes, imaginary lines running from east to west parallel to the equator and north to south from pole to pole respectively. So, every place on Earth has a special location, like its own address. To find it exactly, we use a system called the grid of latitudes and longitudes, imaginary lines that cover the whole Earth like a net. What are latitudes? These are imaginary lines that run east to west, side to side. They are parallel to the equator, which is the middle line around the Earth. Latitudes tell us how far north or south a place is from the equator. What are longitudes? These are imaginary lines that run north to south, top to bottom. They go from the north pole to the south pole. Longitudes tell us how far east or west a place is from the prime meridian, that is 0 degree longitude. Why are these lines important? They help us find any place on the Earth, just like using a map or GPS. If we know the latitude and longitude of a place, we can pinpoint the place exactly. Longitude also marks the time and defines the time zones. The Earth is divided into different time zones, each about 15 degrees of longitude wide. Each time zone is 1 hour apart. So, when you move 15 degrees east, the time is 1 hour ahead. When you move 15 degrees west, the time is 1 hour behind. Longitude helps us keep the time organized across the world and know what time it is in different places. The international dateline is located approximately at 180 degrees longitude, opposite the prime meridian. Crossing the international dateline changes the date by 1 day. The international dateline is an imaginary line around the Earth located at about 180 degree longitude. It is exactly opposite the prime meridian, which is at 0 degree longitude. When you cross this line, the date changes by 1 whole day. If you cross the line going east, you go back 1 day. For example, Monday becomes Sunday. If you cross it going west, you move forward 1 day. Sunday becomes Monday. With this, we have completed the chapter 1, locating places on the Earth. I hope you found it easy to understand. If you want to see more videos like this, don't forget to like, share and subscribe to our channel. Thanks for watching. We will see you again in our next video. Bye bye.